China's labor force is shrinking and aging fast, and the world's biggest manufacturing engine is losing the human fuel it was built on. Beijing's answer is a massive bet on automation, more robots, more AI, and fewer workers per line. The question is whether silicon and steel can scale quickly enough to outrun demographics, or whether the factory model that powered global supply chains is about to change for everyone. China's population story has flipped from growth to decline, and the numbers reveal the scale of the challenge. In 2025, the country's population dropped by 3.39 million, the fourth straight year of contraction. Birth rates have collapsed to their lowest level since the founding of the People's Republic in 1949, with only about one child born per woman, far below the 2.1 needed to keep the population stable. The working age group, defined as ages 16 to 59, now stands at 851 million, but that figure is shrinking each year. Meanwhile, the share of people aged 60 and over is climbing fast, projected to reach 28% by 2040. Behind these numbers, the labor force is thinning out. Fewer young people are entering factories, while the ranks of the retired swell. The old demographic dividend, the advantage of having many workers supporting few dependents, has faded. Now, for every 100 working-age people, there are nearly 23 elderly to support, and that ratio keeps rising. The total labor force participation rate has slipped to its lowest point in 3 decades, with fewer than 2/3 of adults now working or looking for work. These shifts are not just statistical. They mean that factories, once able to draw on a seemingly endless supply of young migrant workers, are feeling the squeeze. Hiring is tougher. Wages have risen as employers compete for a shrinking pool of labor. The cost of supporting an aging population through pensions and healthcare puts new pressure on the economy. GDP growth, once fueled by abundant cheap labor, now faces a projected drag of up to 2 percentage points a year from population aging alone. The numbers speak to a turning point. As China's labor force shrinks and ages, the country's entire production model faces a test. The question is no longer just how many goods can be made, but whether the human engine that powered China's rise can be replaced, or if the model itself must change. On the outskirts of Suzhou, an electronics plant manager scans a hiring board that has been empty for weeks. The factory once had a line out the door, young migrants from the countryside eager for overtime. Now HR posts stay up for months. New recruits trickle in, many older than before, some with graying hair tucked beneath their caps. The average age on the floor has climbed steadily, and the crew that once cycled through 3 shifts now struggles to fill 2. The general manager, Mr. Li, watches the numbers tighten. Each month, he receives more resignation slips than job applications. Old hands stick around, but the energy is different. Younger workers are rare, often drifting away after a few weeks to try delivery gigs or online sales. The plant's labor agency, which used to guarantee a steady stream of replacements, admits it cannot meet quotas. Vacancy periods stretch from days to months. Production supervisors scramble to rearrange teams, sometimes moving managers onto the line just to keep output steady. Wage offers have crept up. In 2015, a new hire might have started at 3,000 yuan a month. Now it is closer to 5,000, with signing bonuses and extra perks. Yet even with higher pay, the pool shrinks. Overtime, once a selling point, is now a burden shouldered mostly by older workers. Fatigue sets in, mistakes rise. Orders that once sailed out on schedule now face delays. The pressure to meet deadlines is constant, but the workforce cannot stretch any further. Mr. Li describes the impact in numbers. Output per worker is down, sick days are up, and the cost per unit has risen for the first time in years. The factory's margins, already thin, are squeezed by the need to keep lines running at any cost. Managers debate whether to invest in more automation, but the upfront expense is daunting, and skilled technicians are hard to find. On the floor, the human side of the demographic crunch is impossible to ignore. aging crews, empty hiring boards, and a sense that the old model is running out of road. Billions of yuan move through the arteries of China's automation drive, directed by a web of national and provincial policies. At the heart of this push sits Made in China 2025, a state blueprint that names robotics, AI, and smart manufacturing as pillars for economic survival. The plan sets clear targets. By 2025, robot density in key sectors should rival or surpass Germany and Japan. The 15th five-year plan, rolling out through 2030, doubles down with new mandates, public funding for factory upgrades, tax breaks for companies that install domestic robots, and procurement rules that favor Chinese suppliers over foreign imports. Local governments, especially in manufacturing powerhouses like Guangdong and Jiangsu, compete to offer the most generous incentives. Industrial parks advertise direct subsidies for robot purchases, sometimes covering up to 30% of the cost. Preferential loans flow to firms willing to automate, while tax holidays reward those that hit productivity benchmarks. In 2023, the Robot Plus Application Action Plan set off a race among provinces to modernize state-owned factories, with targets for thousands of new installations and networked production lines by 2025. By 2025, over 290,000 industrial robots were installed nationwide, more than any other country and nearly half the global total. Central planners are not just funding hardware, they are building entire ecosystems. National innovation centers pool proprietary data for AI model training, while joint research and development labs link local universities with leading robotics firms. The AI Plus initiative, launched in August 2025, aims for 70% penetration of intelligent terminals and AI agents in manufacturing by 2027, rising to 90% by 2030. Public procurement contracts guarantee buyers for domestic robot makers, locking in demand and encouraging scale. The Ministry of Industry and Information Technology tracks progress with quantitative targets: 1,000 industrial AI agents, 50,000 upgraded enterprises, and 120 million connected industrial devices by 2028. Behind these numbers, a new class of systems integrators emerges, bridging the gap between policy and production. These firms orchestrate the flow of machines, data, and capital, translating government mandates into real changes on the factory floor. Their role is less visible than the robots themselves, but they are the architects of China's automation experiment, guiding the shift from labor-driven to machine-led manufacturing. The scale of resource mobilization is vast, but the question remains: can this top-down blitz deliver results before demographic decline outpaces the state's ambition? A systems integrator stands at the heart of a newly redesigned electronics plant in Guangzhou, clipboard in hand, watching as a robotic arm checks circuit boards with machine precision. The old line once stretched with a dozen workers per station, each focused on a single repetitive task. Now inspection cells run with half that number, and some stations need only 2 people to oversee a battery of collaborative robots, or cobots, that scan, sort, and flag defects at speeds no human could match. Automated mobile robots, called AMRS, glide between workstations, shuttling parts and finished goods, and are programmed to avoid obstacles and reroute on the fly. Where once workers pushed carts between assembly and packaging, these machines now handle the flow, mapping the floor in real time. The transformation did not happen overnight. It began with a mandate: cut headcount by 30% without losing output. Integrators mapped every process, identifying bottlenecks where human hands still ruled, especially in quality control and material transport. The solution was a hybrid approach, using AI-powered vision systems for inspection, cobots for repetitive assembly, and AMRS to bridge the gaps. The integrator's job was to make these elements talk to each other, linking sensors, software, and machines into a single nervous system. Each cell is now monitored by a central dashboard, flagging slowdowns or errors for a technician to address. The human role shifts from operator to troubleshooter, with a premium on those who can diagnose faults or recalibrate a robot on the fly. In the stamping workshop, headcount has quietly dropped from 40 to 24 over 2 years. In packaging, a single technician now manages 3 AMRs and a fleet of automated sealers. The integrator points to a wall of metrics. Downtime is down 12%, defect rates have halved, and overtime, hours have nearly disappeared. But the upgrade comes with trade-offs. The plant now depends on a steady supply of replacement parts, specialized software, and a small cadre of skilled technicians. When a robot stalls, a line can freeze for hours if the right expert is not on hand. The integrator spends as much time training staff as tuning machines, aware that every gain in efficiency relies on this new blend of technology and human skill. For now, the redesigned line delivers on the promise: fewer people, higher throughput, and the ability to run around the clock. Yet the integrator admits that not every process is so easily automated. Some tasks, fine adjustments, and complex repairs still require human finesse. The factory's transformation is ongoing, a work in progress shaped by the limits of both machines and the people who keep them running. In a vocational school on the edge of Shenzhen's industrial sprawl, the dean scans a half-empty roster. The government's mandate is ambitious: triple the number of certified robot technicians by 2030. Yet the gap between ambition and reality is stark. In 2025, China counted just 200,000 certified automation technicians. Over the next 5 years, factories will need at least 1 million more. But training programs run below capacity, and students often struggle with the complexity of AI-driven systems. On a whiteboard, job postings for robot integrators outnumber applicants. Salaries climb, but the pipeline narrows, and experienced workers retire faster than new ones arrive. Hardware presents its own choke points. Nearly 80% of high-precision servo drives and robot controllers still come from Japan and Germany, with the most advanced models locked behind export controls. In 2024, Chinese factories imported $2.5 billion in these components, and for the highest-end units, foreign dependence remains above 70%. AI chips are even more vulnerable. Over 90% of processors powering robot vision and decision-making are sourced from abroad. US export bans have already triggered a 50% shortfall in advanced AI chip capacity, halting upgrades in hundreds of smart factories. Even domestic leaders like Huawei can only fill a fraction of the demand, forcing many plants to rely on outdated hardware or scale back their plans. The power grid, too, strains under the load. Doubling China's robot stock by 2030 could add up to 150 terawatt-hours of new industrial demand, an 8% jump. In manufacturing centers like Guangdong, grid planners warn of 15% shortfalls during peak automation cycles. Blackouts and voltage drops threaten to idle entire lines, breaking the promise of non-stop production. Upgrading the grid requires massive investment and years of work. For now, factory managers juggle schedules around power rationing, while officials debate how to keep pace with automation's appetite. The dean puts it plainly: we can build labs and buy robots, but if skilled people, chips, and electricity can't keep up, we're building castles on sand. The surge in automation reveals just how fragile the foundation really is. As China's grip on low-cost, high-volume manufacturing loosens, production capital is on the move. Factory owners, faced with rising wage bills and a shrinking labor pool, weigh their options with new urgency. The old cost calculus, where China's vast workforce delivered unbeatable scale, looks less certain as robot installations drive up capital costs and persistent skills shortages threaten downtime. Investors now scrutinize the numbers, comparing not just wages, but the total cost to automate, maintain, and power a modern production line. In Vietnam, electronics clusters near Hanoi expand as global brands diversify assembly lines. Labor costs there remain a fraction of China's, and while infrastructure lags behind, the promise of a younger workforce draws new factories. Indonesia and Thailand, too, compete for contracts once destined for Guangdong, offering tax breaks and land deals, but it is Mexico that draws particular attention from multinationals recalculating supply chains for North America. Nearshoring trends accelerate as the United States-Mexico-Canada agreement slashes tariffs and shipping times. Mexican labor, at $4 to $6 an hour, undercuts China's post-automation wage equivalent, especially in sectors where full robotization is years away. A manufacturing executive in Monterrey walks through a newly expanded plant, pointing out lines that once ran in Shenzhen. He describes how automation in China has narrowed the wage gap, but not erased it. For products that require frequent changeovers or manual finesse, Mexico's blend of skilled labor and proximity to the United States wins out. The executive's calculations go beyond hourly pay, and he factors in the cost of importing advanced robot controllers, the risk of chip shortages, and the challenge of recruiting technicians in both countries. In his view, automation is essential everywhere, but the speed and cost of scaling it remain uneven. The global supply chain is quietly rebalancing. As China automates to offset its labor shortfall, competitors in Southeast Asia and the Americas seize their moment, offering a different mix of cost, flexibility, and risk. The outcome is not a simple shift, but a complex sorting, one that will define where the world's goods are made and at what price. Three variables shape the future of China's factory engine: robot density, access to advanced chips, and the supply of skilled technicians. The verdict depends on how these levers move by 2028, and each scenario draws a sharply different map for risk and opportunity across sectors. In the optimistic case, robot density in manufacturing hits 1,000 units per 10,000 workers, matching or even surpassing South Korea's current benchmark. Domestic chip makers, led by SMYC and Huawei, deliver 60 to 80% of the high-end processors needed for industrial AI, easing the pressure from US export controls. The technician pipeline grows fast, with 8 to 10 million qualified workers in place, fueled by expanded vocational programs and on-the-job retraining. In this world, electronics and automotive assembly lines run at near full automation, with China's cost per unit dropping below Mexico and Vietnam even after accounting for capital and energy. The country keeps its grip on high-value sectors, consumer tech, batteries, and electric vehicles, while low-margin industries like apparel and toys continue to drift offshore, unable to justify the automation investment. Productivity gains outpace demographic losses, and the factory of the world model endures, albeit with fewer people on the floor. In a constrained scenario, robot density stalls at 400 to 600 per 10,000 workers, held back by chip shortages and a technician gap that leaves only 2 to 4 million qualified staff in place. Domestic chip supply covers just 20 to 40% of needs, forcing reliance on aging imports and limiting the rollout of AI-driven lines. Factory downtime rises as maintenance lags, and integration failures eat into efficiency. In this world, textiles, plastics, and basic electronics bleed to Southeast Asia and Mexico, where labor remains cheaper and more flexible. China's cost advantage narrows or disappears in key sectors, and the global supply chain fragments as brands hedge bets across multiple regions. Most likely is a hybrid path. Robot density lands between 600 and 800 per 10,000 workers. Domestic chips cover 40 to 60% of demand, and technician ranks reach 5 to 7 million. In this middle ground, China retains dominance in sectors where automation and scale matter most: semiconductors, electric vehicles, and complex electronics, while sharing ground in autos and losing ground in labor-heavy industries. Cost parity with Mexico and Vietnam becomes the norm, not the exception. The next 3 years will determine which scenario prevails as the race between silicon and demographics enters its decisive phase. Today, for every new robot installed on China's factory floors, 2 experienced workers age out of the workforce. As the world's manufacturing geography shifts, the race between demographic decline and automation is redefining global supply chains. Whether productivity can truly outpace the loss of people is no longer just China's question, it is every nation's warning. The future of work is being rewritten in real time. What's your perspective? Drop it below.